All right, Algebra 2, Lesson 34, we're going to talk about graphing linear equations. A lot of this stuff overlaps with things that you might have seen if you took geometry, or stuff that you should definitely remember because we're covering this in Algebra 1. So I know that you have seen some of this before. Whether or not you remember it may be a different question, but this has shown up. So graphing linear equations 2, it should also tell us that we've had graphing linear equations 1, so we shouldn't be completely unfamiliar with how to graph linear equations. A relation is a set of ordered pairs, an xy set of coordinate pairs. We're familiar with xy for coordinate pairs. We know that we're going x means I'm going left or right, y means I'm going up or down, and I would plot that on the coordinate plane. Okay, it would be a single point. A function is a relation in which there's exactly one value of y for every value of x. So inputs and outputs, in terms of that, I'm only going to get one output for every input, right? Knowing that, I should be able to, if I have a function, it should pass a vertical line test. Are we familiar with the vertical line test? Okay, good. All right, so at the moment where I have an x value that has more than one y value, I have 2 points that are directly above and below each other that are creating a vertical line. Therefore, they would not pass a vertical line test and therefore would not be a function. So we talk about the vertical line test there. A function with a constant rate of change is called a linear function. All right, say we had something like y equals 2x plus 3. Okay, that's a linear function. What is the rate of change there? Does anybody know? How could we represent rate of change? All right, let's talk about rates, right? A rate would be something like miles per hour, right? Dollars per gallon. Let's see, calories per ounce. So the 2 is my slope, right? Up 2 over 1. That is my rate of change, okay? Let's see. So a function with a constant rate of change, here it's 2, has a constant rate of change. It's called a linear function, and its graph is a line. We're going to start at 3 on the y-axis as my y-intercept, and I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. If I run out of space that way, I can go back to my y-intercept, go down 2, back 1, down 2, back 1, down 2, back 1, plot all of those points and connect them with a line. All right, for every non-vertical line represents a linear function. If I get a vertical line, that means I'm going up indefinitely over 0, right? So if I have a vertical line, the slope is referred to as undefined because even if I knew what the number was, it would be over 0, and anything divided by 0 is undefined, okay, or error, or cannot compute, something to that effect. That is a vertical line, okay? Vertical line has a undefined slope, all right? Whereas a horizontal line continues to go on forever and ever to the left and right, but doesn't go up at all, right? So that would give me 0 divided by a number. What's 0 divided by anything? 0. So a horizontal line has a 0 slope. So horizontal gives you a 0 slope, vertical line gives you an undefined slope. Does that make sense? We'll understand those things. Okay? So a linear function can be represented by a linear equation. There are 3 forms of linear equations that are commonly used. We'll see those on our next slide here. All right, we have the standard form of the equation, which is ax plus by equals c. We could have written that as, 2x plus y equals 3. Okay? That would be an example of the standard form of an equation. Okay? The slope-intercept form of the equation, if we use this same equation, would be y equals negative 2x plus 3. Do we understand that? And how we would do it, how we've changed it. All I did was move the 2x to the other side. I had to subtract it from both sides, giving me the exact same equation. There's no graphing difference between the standard form and the slope-intercept form. Okay? And then we would have the point-slope form. So I would get something like y minus y1 equals m times x minus x1. Now, you need a little bit more information possibly here because I don't necessarily, you would want a coordinate pair that's going to fit on there to plug it into that equation. Off the top of my head, I don't necessarily have that other information other than I know for sure that we would have y minus 3, all right, because 3 is positive, equals -2 times x minus whatever x value satisfied the equation, okay? All right, so the most basic linear function is y equals x. That's the most simple linear equation that we can write. And what we know from this equation, just looking at it, what is the y-intercept of y equals x? 0. All right, so it actually crosses at the origin. And what is the slope of y equals x? Up 1 over 1. Up 1 over 1. That's the most basic form. Okay, that's what we call a parent function, is the most basic form of a type of equation. Is what we call the parent function. Everything else manipulates that basic equation. Okay? Let's see. All other linear functions are transformations of that equation, y equals x. Reflections, shifts, stretches, compressions are all types of transformations. Right? The fact that it has a y-intercept that's anywhere other than 0 is us manipulating y equals x, adding or subtracting from y equals x. Giving a coefficient in front of x is either compressing or stretching y equals x. Does that make sense? Maybe not yet. Okay. Okay. So these are types of transformations that we see. Things that would manipulate y equals x. For instance, if we had negative f of x, well, what is f of x? What are we substituting for there? Y. So negative f of x is a reflection over the x-axis. Okay, we're reflecting it across the x-axis. So y equals x would normally look like this, right? If I'm reflecting it across the x-axis, what I'm doing here is this. That reflects it across the x-axis. And so if I have negative f of x equals x, that would be negative y equals x, right? But if I wanted to solve for just y, I would divide by -1. That would give me y equals negative x. And then the slope is down 1 over 1, down 1 over 1, down 1 over 1, or up 1, back 1, up 1, back 1, up 1, back 1. So do we see how giving a negative y equals x is actually reflecting it, giving me y equals negative x? Hopefully. Was that confusing? It's a lot of words. Okay. All right, so if we have f of x plus c, what that is, it's a vertical shift if c units up is a positive, meaning basically y plus c, we're getting y equals x plus c. So what that does, I'm just going to show you all of this, is that it just, it moves it. If our red line is our parent function, that moves it up. It has the same slope, but it's shifted it up, okay? Now, if c is negative, right, it's going to shift it down, okay? All right, what else? What else affects it? Well, c times y, okay, is a vertical stretch by a factor of c if c is greater than 1. For this case, y equals 2x, all right? Well, that's going to change, or it's going to stretch that slope. So instead of being up 1 over 1, now it's up 2 over 1, right? So it's going to be more like this, okay? But if it's less than 1 but greater than 0, I'm going to get something that's a little bit more horizontal, right? And so that's what we call compression. Okay, it's pushing it down, right? So we would get something like 1/2 x. Okay, now we can do more than one of these at a time, right? We could do y equals negative 1/2 x plus 3, right? And we could do all kinds. We could do shifts and compressions all at the same time. So if a line has a slope of 0, then its equation y equals mx plus b becomes y equals 0x. What's anything times 0? 0, so y just equals b. So anytime y equals, I get an equation where y equals any number, this is a horizontal line. Okay, let's say y equal 3. Then what I would have is I would count 1, 2, 3. That would be my line. Okay, and that's really confusing to a lot of people because we think of y as the y-axis. The y-axis goes straight up and down. Therefore, y equals should be vertical lines. It's not. Okay, because, and this is what I want you to understand, y represents these horizontal tick marks, right? Okay, the line of the y-axis is actually the equation of the line x equals 0. The y-axis is the equation of the line x equals 0 because x equals 0 at the y-axis. Do you follow me? And the, let's see, the x-axis is the line y equals 0. Okay? Because y equals 0 at the x-axis. Does this make a little bit more sense? I know it can be kind of confusing because your brain doesn't necessarily operate that way with what you've, kind of been, I don't know, what your brain leads you to think, I guess. So horizontal and vertical lines. If we let b be any constant, y equals b is a linear function whose graph is a horizontal line. And it will be a function because a horizontal line will always pass the vertical line test, right? Okay, should never have a problem. So you get something like y equals 4, similar to what we saw with y equals 3. Now, x equals b is never a function, ever, because it's a vertical line. Can't pass the vertical line test. So it's not a function. Its graph is a vertical line with an undefined slope, meaning that if I had something like this and I had x equals 4, I'm going to count over 1, 2, 3, 4, right? Okay? It's going to look like that. So this is, I think, maybe an easy way to remember is look at how the tick marks are oriented. Okay? If it's x equals, I'm going to go on the x-axis and I'm going to mark and I'm going to draw a line that is the same as the tick mark. So if it's up and down, it's up and down. Right? If it's y equals, I'm going to be on the y-axis and I'm going to follow the shape of the tick mark. Right? The tick marks on the y-axis are all horizontal. Does that make a little bit more sense? All right, and so the slope of any x equals is undefined because it's a number with no run, right? It's 0 run. Rise and fall, but no run. So it would be a number divided by 0, which is undefined. Okay, that's the end of that at least. Let's try to look at some questions here. All right, so question number 1 says, write the linear equation negative 5x minus 10y equals negative 40 in slope-intercept form, then graph the equation. So if I want to rewrite an equation in slope-intercept form, what do I first want to do, Diego? Slope-intercept form? Yeah, I want to move this over to slope-intercept form. Yeah, okay, I know what the slope-intercept form is. How do I manipulate that equation? What do I do to it?
You put negative 10y equals negative 5x minus 40.
Close. You got the negative 10y part, and you got the negative 40 part, but saying that it's negative 10y equals negative 5x minus 40 is wrong. Well, how did I get the 5x over there? How do I move that negative 5x to the other side? I added over, right? So what's negative 5x plus 5x? 0. I need it to cancel, right? So that it's no longer over there, right? Then I'm going to add that 5x over here. So I don't have negative 5x. I have positive 5x. But I'm not done yet. I'm not in slope-intercept form. I'm not in slope-intercept form until I have an equation that says y equals, right? Allison, what would you do from here? Divide by negative 10 on both sides. And what do I divide by negative 10 on the right-hand side? Am I dividing just the 5 or just the 40 or all of it? All right, so I'm getting y equals, what's 5 divided by negative 10? Negative 1/2. Negative 1/2 x. What's negative 40 divided by negative 10? Plus 4. What does the 4 represent, Danielle? The y-intercept, right? Okay. And what does the negative 1/2 represent, John? All right, so I want to start from 4, and I want to go down 1 over 2, down 1 over 2. Is there a graph up here that represents this anywhere? Right? And you'll notice on all of these have the same equation, correct? But only one of them has the right graph. Which one is it? A, right? And we could find something wrong with all of them. This one has the y-intercept at -4. This one down here, D, has the y-intercept at 4, but it's going up 1 over 2. And this one over here on B, I think shows me y-intercept at 4, but it looks like it's going down 2 over 1. Okay? So hopefully that makes some sense to us. Okay? We could graph the linear equation, 2x minus 2y equals 4. There's also another way to do this if you're interested, is that we could find the x and y intercepts. Are you guys familiar with x and y intercepts at all? X and y intercepts is where I would make a table of values, x and y. Now, if I wanted to know where the equation crossed the x-axis at, I would plug in 0 for y, right, which is going to cancel out that whole section. So I will get 2x equals 4 and solve for x, right? So I'm going to divide by 2, right? What's 4 divided by 2? 2. And then if I wanted the y-intercept, I'd plug in 0 for x, right, which would have me do that there, right? Now I have -2y equals 4. I'm going to divide by -2. What's 4 divided by -2? -2. And so all I have to look for is I'm going to plot 2, 0 in 0, 2, right? So 2, 0, okay, that would give me something like right there. And 0, -2 would give me something like right there, right? Does that make sense? I only have to plot 2 points that way. Now, could we have done the y-intercept form of that equation? Sure, right? I'm not trying to tell you not to do that. I'm just saying I'm trying to give you another tool that you can put in your toolbox. Okay? Questions about that? All right. And you should have learned that in Algebra 1, and I know you should have learned that in Algebra 1 because I taught it in Algebra 1 today, like before you walked in. Okay? Let's see. Graph -10x minus 3y equals 30 by solving for y to obtain slope-intercept form. Let's see. John, help me out here. You want to solve for slope-intercept form. What are you going to do first? Good job. Divided by -3. All right, so you're getting y equals what? Yep, -10 x minus 10. All right, so we're going to start where? -10 on the y-axis, right? But it has a negative slope. I don't have any more graph to go down. What do I do? I can't go down any further on this graph. I go up what? Up 10, left 3. Okay? So I do that, and then I almost need to use a ruler, but we'll do the best I can. Yeah, that's not great. That's pretty bad. Okay, but you could do better with a ruler or something like that. Get you a straight edge. But yeah, that's absolutely right. All right. How do we feel about this? Do we feel like we've got this? Just leave me alone, let me do my homework, or do a couple more? What do you want to do? We got this? Okay, you guys are out of here, what, 36? Okay, so that's about right on time anyway. I don't know that there's really any others in here. Let's look at this one real quick, though. X equals -4. What kind of line is that? It's vertical, right? So I'm going to go over. Danielle, where am I going to go to draw this vertical line? Left 4. Okay, so I should get that line right there, correct? Okay, good. All right, let's see if there's another one in here at all similar to this. Nope, that looks like that's it. Okay. All right, we'll stop there, let you guys get to work, and help you out as much as I can.